Welcome back, students. We are continuing our journey to learn about the exponents and power. This is for standard 8, chapter number 10, and today we are going to solve the questions from exercise 10.1, and we have around 7 big questions, and under each question we have around 3 to 4 sub questions. So technically speaking, we will have around 25 to 30 questions that we will solve today. So let's get started. Welcome back, students. In this video, we will continue our learning journey to understand the chapter Exponents and Power. This is for standard 8, chapter number 10. And today we are going to solve the exercise 10.1. I am able to see within the book we have 7 major questions out over there, and under each major questions we have around 3 to 5 sub questions also. So we will technically then solve around 35 questions today. So stay tuned and continue to see the video till the end so that you can learn the best of ways and means to solve the exponent and power questions. And we will also follow all the law of exponents that we have learned in the previous video. If you have not seen my previous video on exponents and power, I will strongly encourage that there's a playlist that I have put together. You go in that particular playlist and see all the videos already uploaded on exponents and power chapter, where I have explained the law of exponents in extreme detail. Also, a small request, if you are liking the quality of the content here, if you are able to learn, then please do like and subscribe to the channel, and also share this particular channel with your family and friends so that others can also take the benefit from the rich content that I am putting in this channel. So with that, let's just start with the first question. Question number 1 is evaluate 3 raised to the power of 2, and the first thing that we will do over here is to convert the negative exponent out over here into the positive one, and as per the inverse law, the negative exponent law, which is basically wherein a raised to the power of minus n can be written as 1 by a raised to the power of n, in order to convert the negative exponent into the positive exponent. And this is basically as per the law of exponents. So we will apply the same treatment in this particular question as well. So we will say 1 3 by 2 as per the negative law. And if we will further continue, we can write this as 3 into 3, because we have 2 as the power to 3, and your answer will be 1 by 9. We will look at question number 2 now. Question number 2 says minus 4 raised to the power of negative minus 2, and we need to evaluate this question again. We will follow the law of exponents again, and this time we will follow again the negative inverse law, which says that if you have a negative power, you can convert that into the positive power by doing something like this. So a raised to the power of negative n can be converted into 1 by a to the power of n. So let's try and apply this over here. We already know we have minus 4 raised to the power of minus 2. This can be written as 1 by minus 4 raised to the power of 2, wherein your negative power will get converted into the positive exponent or power. And then you can say 1 by minus 4 into minus 4. This will be 1 by 16, because 4 into 4 is 16, and then negative symbol will go once you will multiply this. Okay, so we will look at question number 3 now. The question number 3 says 1 by 2 raised to the power of negative 5. We will again follow the same law, which is negative inverse law. And herein you will convert your negative exponent into the positive exponent. So we will follow the same concept here. This will be 1 by 2 raised to the power of minus 5, which we already know. Then we will write 1, which is this here. And then 1 by 2 raised to the power of positive 5, right? And then this will be 1 by 1, which is this, multiplied by, we are going to inverse this also. So this will become 2 by 1 raised to the power of 5. And your answer will be 2 multiplied by 1 will be 2, 1 multiplied by 1 will be 1 raised to the power of 5, and your answer will be 2 raised to the power of 5. Very quickly, we have solved 3 questions so far. If you will notice under this question number 1, which says evaluate, the first one was 3 raised to the power of negative 2. We have applied the law of exponent, which is negative law or negative inverse law, and when you do this, when you inverse this will become 1 by 3 raised to the power of 2, and when you multiply 3 into 3, you will get this answer, which is 1 by 9. The second question is also based on the negative inverse law, where you need to convert the negative exponent value into the positive one. So we have done the same thing, we have inversed that. And by doing this, the expression became 1 by minus 4 raised to the power of 2, and then when you do the multiplication, your answer will be 1 by 16. The third question under this particular category was 1 by 2 raised to the power of negative 5, and when you did the maths again, which is basically converting the negative exponent into the positive one with the help of same law here, it came out to be 2 raised to the power of 5. And alright, so we have solved 3 questions so far. Let's move to the next question that we have. So we are looking at question number 2, and for your convenience, I have already noted down the question so that we can quickly get into solving the problem that we have in front of us. Question number 2 says simplify and express the result in power notation with positive exponent. So we need to basically solve the expression given to us and make sure that the answer that we will deliver is in the positive exponent, right? So we will solve this question, and the question we have is minus 4 raised to the power of 5 divided by minus 4 raised to the power of 8. So looking at the question, we have 2 same bases out over here, and we will use the law called quotient with same basis. What does this basically suggest is that if you have same basis, which is a raised to the power of m divided by a raised to the power of n, then you can do a raised to the power of m minus n. So you have same basis with different exponent, and then you can do the subtraction here. So we will also follow the same law over here this time, and we will say we already know minus 4 raised to the power of 5 divided by minus 4 raised to the power of 8. This will become minus 4 raised to the power of 5 minus 8. This will become minus 4 raised to the power of minus 3. And when we will convert, because we need to convert and give our answer in the positive exponent as per the question. So when we will convert this negative exponent into the positive, we will have to apply a different law of exponent, and that different law of exponent is basically called as law of negative inverse, wherein you can convert a raised to the power of minus n, you can write something like a raised to the power of positive n in order to get the positive exponent. So in this case, we will convert minus 4 raised to the power of minus 3. This will become 1 by minus 4 raised to the power of positive 3, and that will be your answer. I hope it is clear. The question was to solve the expression over here, which has which has same basis, and we applied two law of exponents out over here. One is the quotient with the same basis, and the other one is the negative inverse. In the quotient with the same basis, you can give this kind of a treatment. So this is exactly we have applied to our expression, wherein we have said minus 4 raised to the power of 5 minus 8. We received something like this. And given that we had to convert this negative exponent into the positive one, we have applied another law called negative inverse, and with the help of negative inverse, we have got this answer. With this, I will move on to the next question that we have under the question number 2. Alright, the second question that we have under question number 2 is 1 by 2 raised to the power of 3 overall raised to the power of 2. This is an interesting question again, and we will apply the law called law of exponent. And as per my video, this was law number 3 that we solved or we learned last time around. It says power raised to a power, and in this case your equation will look something like this, right? So we will follow the same law over here, which is law number 3 based on the videos that I have created, and this law is about power raised to a power. So let's see how we can apply this in this context. In addition to applying power raised to a power in this particular question, we will also apply law number 7 that we learned in the video that I put together, which says negative inverse law. And negative inverse law is again a law that helps us convert the negative exponent into positive and positive exponent into negative. So if you have something like this, you can write something like this in order to convert the exponent from negative to positive or positive to negative. So in this case, let's just quickly see what we have. We already have 1, 2 raised to the power of 3 overall raised to the power of 2. We will inverse this, and we will say 2 raised to the power of minus 3 by 1 raised to the power of 2. And here I am using law number 7, which is negative inverse law, and I'll explain you why I have done this. Now you are left with 2 minus 3 raised to the power of 2. And now we will apply power raised to a power, which is basically a raised to the power of m overall raised to the power of n, and we can do something like this. So this will become 2 minus 3 into 2, and this will become 2 minus 6. And in order to give a positive exponent answer, we will again apply the negative inverse law over here, and this will become 1 by 2 raised to the power of 6 after applying the law number 7, which is negative inverse law. And this is eventually going to be our answer for the question, 1 by 2 raised to the power of 3 overall raised to the power of 2. Okay, so we will move to the question number 3 now, and question number 3 says minus 3 raised to the power of 4 multiplied by 5 by 3 raised to the power of 4. So this is the expression that we need to solve with the positive exponent. So when we have same exponents with different bases, we can use the law number 4 that we have learned in the past in the previous videos. And the law number 4 says product to a power, and this says if you have two different bases, which is a is one base to a common power multiplied by b, which is the second base with a common power, you can always write something like ab raised to the power of n. So we will apply this particular law within the expression that we have. So we already know it is minus 3 raised to the power of 4 multiplied with 5 by 3 raised to the power of 4, and we can say minus 3 into 5 by 3 raised to the power of 4 based on what we have learnt over here, which is law number 4, product to a power, and then we can do basic maths. This will become minus 1 into 5 raised to the power of 4. Then we can say minus 1 raised to the power of 4 into 5 raised to the power of 4. This will become 1 into 5 raised to the power of 4, and this will become 5 raised to the power of 4, which and this is your answer. So very quickly, let's see what we have done in this particular question. Our question was minus 3 raised to the power of 4 multiplied by 5 by 3 raised to the power of 4. We had common exponents, but the bases were different, and hence we applied this law number 4, which says product to a power, and this is the expression where you have two different bases but common exponents, and you do this kind of a treatment. And then we have done the same thing. We have multiplied minus 3 with 5 by 3 with the common exponents, and after doing the basic math, your answer is 5 raised to the power of 4. We will now move to the next question. Question number 4 says 3 raised to the power of minus 7 divided by 3 raised to the power of minus 10 multiplied by 3 raised to the power of minus 5. Again, we will have to apply more than two laws over here. The first law is going to be quotient with the same basis, law of exponent that we will apply, quotient with the same basis. In this case, a raised to the power of n divided by a raised to the power of m. We will say a n minus m. So this is what we are going to apply right now, and the other quotient that we will apply we will see in some time. That will be product with same basis, a raised to the power of m multiplied by a raised to the power of n, and this will become a raised to the power of m plus n. So let's see how we will apply these two laws, and this was law number 2 in my video, and this was law number 1 in my previous videos if you want to follow and go back and check. Let's bring down the question again. So this will be 3 raised to the power of minus 7 divided by 3 raised to the power of minus 10 multiplied by 3 raised to the power of minus 5. Let's apply law number 2. This will become 3 raised to the power of minus 7 minus 10 into 3 raised to the power of minus 5. This will become 3 minus become plus multiplied by 3 raised to the power of minus 5. This will become 3 plus minus 3 raised to the power of 3 multiplied by 3 raised to the power of minus 5. This will become, and now we will apply law number 1, which is product with the same basis, to give this treatment, and hence this will become 3 raised to the power of 3 plus minus 5. This will become 3 plus minus 3 minus 5. This will be 3 plus minus 2, and given we have the negative exponent right now, we will convert this into the positive exponent by converting or applying the negative inverse law. We will apply the negative inverse law, and this will become 1 by 3 raised to the power of 2, which will be basically 1 by 3 raised to the power of 2 is your answer. So we have applied 3 different laws over here: quotient with the same basis, product with the same basis, and inverse negative law. The first one we applied over here, law number 2. Then we applied law number 1 here. And finally we applied law number 7 here. Here we have said n minus m. After doing the basic math, we received 3 raised to the power of 3, and then given that we had the same basis with different exponent and with multiplication symbol in between, we have applied product with same basis. This is what we received. Given we were having the negative exponent out over here, in order to convert the negative into the positive, we have applied negative inverse law, and this is the answer we have received. Alright, so I hope you are gaining from the explanation and step-by-steps that we are taking over here. I will make a humble request for you to like, subscribe, and share this particular channel with your family and friends as well. Let's look at question number 5 under question number 2 that we have. And question number 5 says 2 raised to the power of 3 multiplied by minus 7 raised to the power of minus 3. Again, we have 2 different bases but with similar exponents. And in this case, we will apply law number 4. Law number 4, as per our video, says product to a power. And the product to a power is basically a raised to the power of n multiplied by b raised to the power of n is equal to a b raised to the power of n, right? So let's see how we can apply this particular law in our question. So this, what we already know is 2 raised to the power of minus 3 multiplied by minus 7 raised to the power of minus 3. This will become 2 multiplied by minus 7 raised to the power of minus 3. This will become minus 14 raised to the power of 3. We will apply law number 7 now, which is negative inverse law. Why we will apply negative inverse law? Because we need to convert the exponent from negative to positive. So this will become 1 by minus 14 raised to the power of 3. Your answer will be 1 by minus 14 to the power of 3. I hope it is clear. We started with product to a power where we have clubbed 2 different bases together, and this is what we received. We realized that our exponent is in negative. In order to convert the negative exponent into positive, we have done something like this by using the law of exponent, which is negative inverse law, and this is eventually the answer that we have received. Alright, so we have solved 5 questions under question number 2. Under question number 2, we have solved 5 questions. Under question number 1, so far we have solved 3 questions. So in total, we have already solved 8 questions. Let's look at question number 3.